Hello students, today we move on to the next chapter. The previous chapter we learnt about dual nature of matter and radiation, and today we will begin with atoms. We already know what is an atom. Atom consists of a positive nucleus with protons which are positively charged, with neutrons which are neutral charge, and the electrons revolve around the nucleus. So this is what we learnt it right from 6th or 7th standard whenever we study about atom. But let us go to the origin of the atomic model. The first model was by that of J.J. Thomson. Okay, see, this is the person, the scientist who discovered electrons, and electrons were discovered in 1897. Okay, till then atom was supposed to be unbreakable. John Dalton's atomic theory. Now here J.J. Thomson says that atom is breakable, and first particle what he found was electrons. Okay, so electrons were discovered in 1897, which is electron. Now what was this model? What he thought, that atom is basically consists of positive charges. The whole atom consists of positive charges, right, in which electrons are embedded. We say electrons are embedded, right. Now this is what was the thought of J.J. Thomson. Now this is also called watermelon model. Watermelon, you see watermelon which comes in the summer season, right? The whole red part, it is, you can imagine to be positive nucleus, and the seed, the black seed, the seeds are like electrons. That is watermelon model. Or also we can call plum pudding model. See, when you have a plum cake during Christmas and New Year, you will see that cake is there and plums are being put like that, you know, small pieces, and like that this was the model. But there is a drawback in this model. According to this model, where positive and negative are together, it cannot be stable. Positive and negative are together, one, it cannot be stable, and second, there is something called spectrum. Okay, spectrum, you will be learning more about it. Spectrum analysis, spectral analysis. This was happening before itself, right? In 1800 itself, scientists were working on spectrum, because we look at the sun's radiations are coming, and you can observe it in a plate, photo plate, we can study about it. So already spectrums were available, yes, but they didn't know much about atom, what atom consists of, all these things they were not knowing. So the spectrum, when you see from the sun, you will find that they are actually having lines in that, right? They have lines, and this is called line spectrum. Okay, this line spectrum cannot be explained with J.J. Thomson's atom model. And I also will tell you what is continuous spectrum. Opposite to line spectrum is continuous spectrum, where the colors are continuous. Yes, they all merge. You know what are the colors we have got here? Violet, VIBGR, okay, VIBGR, right? All the colors will merge with each other. It is just like a rainbow. In rainbow, how colors are merging with each other, and that is actually continuous, right? And the spectrum you obtain also will have continuity, right? And there is no perfect demarcation, and that is called continuous spectrum. And line spectrum, where each color will be predominantly having a particular position. So this also cannot be explained by J.J. Thomson's atom model. So this was a initial stage. We can't say it's a failure. it's the first stage actually. You know, stage by stage the development is taking place, right? So somewhere the beginning has to take place, but it was J.J. Thomson who said that there is a negative particle and that is electron. That credit goes to J.J. Thomson. Okay. After J.J. Thomson's student Rutherford, Ernst Rutherford, he came up with another model, right? This is Rutherford's atom model. Yes. Now what is this model? It's much more better. He was a student, J.J. Thomson's student. He thought that if the protons are kept inside the nucleus, if I remove the electrons outside, how it will be? See, this is how scientific discovery and scientific thinking goes on. The teacher thinks both of them together. The student says, okay, I will remove the electron outside. So he removed the electron outside and he looked at a better model. Yes. And according to this, again there is two drawbacks. Yeah. But he did an experiment in order to show that the electrons are outside. And that is gold foil experiment. Okay. It's called gold foil experiment. So this is the first thing he did. He took the electron out of the nucleus and he said that the electrons are revolving around it. Yeah, this is what he said. But basically the concept is, how did he achieve at that point? How did he get into that point? Yes, let me just explain it very neatly for you. Okay, this is gold foil experiment. In gold foil experiment, you find that there is a gold foil, right? And you know, gold foil has atoms in it. Fine, good. Now, he bombarded this gold foil with alpha particle. Alpha particle is the nucleus of helium atom. Nucleus of helium atom. When you bombard this with alpha particle, some observations are made, right? And what is the observation? Let me just draw it here only, right? What is the observation? If you want, let us take the gold foil a little closer. Fine. And the observation is, the majority of the alpha particle went without deviation. Nothing happened to this alpha particle. They just went straight past. Okay, so they all went straight past, majority. Then some of them, alpha particle is positive charge, keep that in mind. Some of them came close to the nucleus and they deflected. And they came close to the nucleus and they deflected some of the alpha particles, right? And some of the alpha particles went head on. It went head on close to the nucleus but retraced the path. They again retraced the path. Now, if an alpha particle which is positive charge is coming till the point and retracing the path, what does that mean? That means the nucleus is consisting of positive charges because electrostatic repulsion is taking place between two like charges. Positive will repel. So from this gold foil experiment, it was concluded that majority are going without deviation, which means there are a lot of empty space in the atom. The first conclusion is empty space is in the atom. Yes. And second point, some of them are deflecting. That means there is something positive and some of them are retracing the path, which means the nucleus consists of positive charges, and positive charges having mass. So the whole mass of the atom is condensed inside the nucleus. Keep it in mind, this is happening in 1911, 1913, and 1897 electrons were found, and next this time still we only talk about negative charge and we talk about positive charge. Still neutrons have not come in, discovered. That was in 1932. Look at the space of time, 1932, 12, 22, 32, 20 years. Then only nucleus was having the neutron they could identify, and the credit goes to James Chadwick. This is protons, the credit goes to Goldstein, right? So what we understand here, we bombard with the alpha particle, there is a gold foil, and this is the observation being made. Okay, so in this model, that is why the electron, where the electrons are then? Electrons are now moved outside the nucleus. That is what is going to happen, and you will find that the electrons are out of the nucleus. So the nucleus consists of positive charges, fine, and the electrons are outside. Yes, electrons are outside, and this is called a planetary model. Like in planet, you have sun at the center and the planets revolve around it. Let us say Earth is revolving around it. Yes, this is called planetary model. But again, there is a drawback for Rutherford's atom model. And what is the drawback? Rutherford just said the electron is revolving around. If electron is revolving around, yes, now we are going to explain two things. One is stability and another is line spectrum. We have to explain these two. First, let us think about both of them. Let us consider together. Electron is revolving around. Any charge which is oscillating should give out energy. An oscillating charge, a moving charge should give out energy. If it gives out energy, what will happen? Can it maintain the circular path? Can it maintain a circular path? It is not possible. It is losing energy. So what it will do? It will come down here, it will come down here, it will come down here, come down further, and it will fall into the nucleus. Okay, it will fall into the nucleus. When it falls into the nucleus, we go back to the Thomson's atom model. Again, it could not explain stability. And if you see in this, if the electron is coming from like this, slowly reducing the orbit and fall into this, the spectrum obtained will be continuous spectrum. Okay, in continuous spectrum, all the colors will be overlapping with each other. So again, this model cannot withstand this drawbacks. So it has to be a failure. Yes, again I said to you, failure we should not call. It is one step ahead towards the success, right? Failures are the stepping stones for success. We all say failures are stepping stones for success. Okay, then comes Niels Bohr. Yeah, next person comes into the scene, that is Niels Bohr, and this is called Bohr's atom model, atomic theory, you can say. Yeah, I will discuss about this in the next video, more derivation on that, but I will tell you what is this model. Again, he is also student of J.J. Thomson and also working with Rutherford, right? Now, what he said, now let us see what he said. Now this is the positive nucleus, fine, let it be, and the electrons are outside, great, It is correct. Electrons are outside. Now the electron should not emit energy. Yes, if I put the condition that it should not emit energy, then what will happen? It will not fall back into the nucleus. That means the spectrum will be line spectrum. It will not be continuous spectrum. We can justify why it should be a line spectrum later. So it was the classic thought of Niels Bohr. You see, J.J. Thomson and then Rutherford, and then comes Niels Bohr. He says electrons revolve around the nucleus, but in non-radiating orbits. This is the classic point which we brought in, non-radiating orbit. If you say non-radiating orbit, it is also called permitted orbit. Yes. Now this is more precisely, you can think of a planetary model. You see, the sun is here and earth cannot revolve anywhere as it wishes. It has to go in a particular path, in a particular orbit, and like that the Bohr's atom model says the electrons revolve around in permitted orbits, and these orbits are non-radiating. Yes, and we will learn more about it in the next video, but today I would like to do a small derivation based on Rutherford's atom model, right? And with that you will be able to complete one small unit of it, right? Now what is that? I am going to tell you now. See, this is, just one second please. Yeah. Yes. Okay. Now this is going to help you to find the size of the nucleus, or we can say discussion is distance of closest approach. It helps to find the size of the nucleus, and the discussion is distance of closest approach. We calculate this distance, radius, we can easily find out the size. How is it done? Very simple. Take the positive nucleus. Now what is the nucleus? Gold. Nucleus, you know, number of protons are equal to number of electrons. So let us say electrons are E. The atomic number of gold, let us say, is Z. Any atom can be expressed as XAZ. Z is the atomic number and A is the mass number. You know that atom is electrically neutral. That means number of protons is equal to number of electrons. So I have got here Ze protons, right? And now I am bringing an alpha particle. It comes to the closest point and retraces the path. Okay. Now what is coming actually? The alpha particle. Alpha particle is 2e. Why? Helium 4 2. 2 is the atomic number, E is the electronic charge, because number of electrons is equal to number of protons, so that atom is neutral. Fine. Now this is coming to the closest approach, right? And this distance we will call it as R0. R0 is the distance of closest approach. From this I can find the nucleus, closest approach, very close it is going, and if I calculate that I can find the size of the nucleus. So how do we do that? Yes, I got alpha particle and I am hitting it, right? That means it possesses energy, it is moving. So what energy it possesses? Kinetic energy. I call it as kinetic energy initial kinetic energy. Whatever energy I give to the alpha particle, over. I cannot do anything. Once I project it, it is done. Now, you know, according to law of conservation of energy, kinetic energy should be equal to potential energy. Now, what is this potential energy? It is electrostatic potential energy. Now, what is electrostatic potential energy? Coulomb's law, we used it there. We found that 1 upon 4 pi epsilon naught into the two charges Q1, Q2 divided by R. This was the formula. Try to remind it, try to remember that and see the old video. That is equal to 1 upon 4 pi epsilon naught into, what are the two charges involved? One is 2E and another is ZE. Okay, 2E into ZE divided by R. What is R here? R naught. Why it is R naught? It is distance of closest approach. Once we know that, okay, we have to make some calculation here. I think I should erase this part here so that we can solve it in this area. We know that kinetic energy initial is equal to potential energy. So kinetic energy initial is equal to potential energy 1 upon 4 pi epsilon naught into 2Z E square divided by R naught. What am I trying to find out? R naught, that is equal to 1 upon 4 pi epsilon naught into 2Z E square divided by, bring the kinetic energy here, kinetic energy initial. This is the formula for the distance of closest approach. From distance of closest approach, we can find the size of the nucleus, right? And kinetic energy initial will be given in million electron volt. Yeah, that will be directly fixed for you, and you know 1 by 4 pi epsilon naught value. Okay, and 2Z, Z of the 79, Z for gold is 79, E you know, so you can solve it easily, right? With this, we have done as first part of the atoms chapter, and the next one will be Bohr's atomic theory and related topics, right? Thank you so much.